Hi guys, I'm Ankit. In this video, we shall see another problem of LeetCode. Count binary substrings. Given binary string, return the number of non-empty substrings that have the same number of zeros and ones, and all the zeros and all the ones in these substrings are grouped consecutively. So the question says we have to return the substring such that that substring should contain equal number of zeros and equal number of zeros and ones, and all the zeros and all the ones should be grouped together. They should be consecutively present. Substrings that occur multiple times are counted the number of times they occur. So if we take the example, this example, let's say a simple example we will take. What are the substring we can found with equal number of zeros and ones and with zeros and ones grouped together consecutively. So 10 is one substring. In that one we have, 0 also, 1 is there, 10 also we have. Again, if you take for next here, 1 is there, 10 is there. Again, if you take this, okay, let me just write this. Okay, it's nothing but 10101, 10101. So if you do, this is one substring, then here this is one substring, then for this one this is one substring, then again you find 10 substring, again in the above 101 substring. So how many substrings? 1, 2, 3, 4. 4 substrings are present. So in these substrings you could see equal number of zeros and ones are present and they are consecutive. That only one zeros and one is present. But if you take this example again, 0, 0, 1, 1, 0, 0, 1, 1. So if we take this example, 0, 0 cannot be. For this 0, no. 0, this 0 can be with this 1. So one substring will be this 0, 1. Another substring could be 0, 0, 1, 1. Then if you go here again, 1, 0 is a substring, 1, 1, 0, 0 is a substring, then 0, 1 is a substring, then 0, 0, 1, 1 is a substring. But you might say the entire thing can be a substring 0011 001 because we have equal 4 zeros and 4 ones. No, this cannot be a substring. The entire string cannot be a substring. Why? Because here 1 and zeros are not consecutive. First 0 0, then 1 1, again 0 0 1 1. No, that cannot be substring. But if you check this example, 0 1 consecutive, 0 1 after 0 only 1 is present. Again 1 0 after 1 1 is present. If you take this example 0 0 1 first zeros then ones. Again if you take this example first ones then zeros. Ones and zeros are consecutive. Again if you take last example 0 0 1 1, even there first we have zeros then followed by ones. So consecutive zeros and ones should be present and they should be equal in number. That is the what question is asking for. So what is the approach to solve the problem? So in this question you could see 1, 2, 3, 4, 5, 6. 6 substrings are present. Is it right? Yes, 6 substrings are present. We have to find the total number of substrings. So what is the approach to solve the problem? So what we'll do is, so initially we'll have a variable called current count. Okay, let be initialized to 1. What is the current count indicates is pointer pointing at this position. Current count is 0, that is initialized to 1. Okay, current count 0 is taken as 1 count. And another count will have a previous count initialized to 0. Total count also initialized to 0. Why are we taking all this? I shall explain the intuition behind that. For now, just imagine we have a current count equal to 1. That is the first 0. So when you start the loop, since we have already have the current count equal to 1, we start the loop from the next next character. Why am I starting from the next character, not the first character? Because here we need to check whether this character is equal to previous character. That's the reason I'm starting from the second character, not the first character. First index I'm studying, because if I start from 0th index, you will not have any other previous element to compare it with. So we will not take that. So now you compare. Okay, it's nothing but string of I, if it is equal to string of I minus 1. To check this, we are starting from the first index. We will not start from the 0th index. So the 0th index, whatever count you have, you initialize current count equal to 1. So that is the one intuition. So now we start from here. Check whether string of I is equal to what? String of I minus 1. If 0 is equal to 0, so what do you do? If 0 is equal to 0, the current count, whatever you have, it gets incremented to 2. Because 2 zeros is indicated. Current count means current number, whatever it is pointing to. You might say, how does it know it's whether it's 0 or 1? No. For that, we have previous count. We'll understand why are we taking that. So once this is done, okay, move to next thing. Now check, s of I is equal to s of I minus 1? No, 1 is not equal to 0. Now it converts. Now you got to know, because binary string contains only two numbers, zeros and ones. So if current count is 0, previous count is 1, previous count will be 0, or if previous count is 0, current count will be 1, so vice versa. So now you find the number which is not equal to previous number. So that means now what you have to do is, we'll find a total count that will be minimum of previous count comma current count. Again, I'll tell why are we doing this. Okay. For now, just you might say this 01 is a substring, but no, we are not taking that into consideration now. When we'll take that into consideration, you might tell this 01 is a substring, but why are we not incrementing the total count to 1? So how do we get that? That we'll get to know. For now, just um, calculate total count equal to minimum of previous count comma current count. What is that? 0. Right? Previous count is 0, current count is 2. Now total count will be 0 itself. Now what to do is, now previous count will be equal to current count. Now initialize previous count equal to current count, and initialize current count equal to 1 again. So why? Since we have found a character that is not equal to previous character, so this is the beginning of a new character. So what we do, the whatever previous count we have, that will be the current count we have, that will be initialized to previous count. So previous count will become 2 now, and current count will be reinitialized to 1 because a new fresh start, a fresh character, a new character is found at this position. You start with the fresh start. So here we have current count equal to 1, previous count equal to indicates previous count means the current count whatever was there was previously, that has become the previous count now. And whatever character you have now, you take the current character count as 1 for it. So again I'll explain. You start iterating. So first you have initialize current count equal to 1. Why? Because we are comparing each element with the previous element. So you start with the 1 for initial character. Next you check this character is equal to previous character. If it is, just increment the current value. Current count will be incremented. If in case if it is not equal, 1 is not equal to 0. In such case what to do is, you find a total equal to minimum of previous and current count. Why are you doing this? I'll tell you. Next, previous count equal to current count. So what is previous count? Previous count is, okay, what is current count? Current count we had as 2. So that will become the previous count, and the current count will be the new character whatever. So current count will be reinitialized to 1. So now once this is done, again move the pointer ahead. Is 1 equal to 1? Yes. Current count will be incremented to 2 again. Okay. Now I again move the pointer ahead. Whether 0 is equal to 1? No. If 0 is not equal to 1, now what should do? This pointer. Total count will be minimum of previous count comma current count. What is that? Both are 2. So what will be the total count now? This will be updated to 2. Now you might ask, why are we updated to 2? What does it indicate? See, as I said before, here only we had when we had the pointer here, you could find 0, 1 is a substring. Another pointer when we pointer went head is 0, 0, 1, 1 is a substring. So if two zeros, two previous count and two current count, if it is present, that means either two ones and two zeros are present. The previous count will be pointing to the character will be 0 or 1, or anything it might be. So two previous count, two current count means two zeros and two ones are present. So that is why if two zeros and two ones are present, how many substrings with consecutive ones and zeros can be formed in that? Only two, right? One is 0, 1, and there is 0, 0, 1. You might have 0, 1, 0, 1, but in this case, zeros and ones are not consecutive. So that is why if we have two zeros and two ones, then two substrings. If we have 1, 0, 1, 1, one substring. And if we have three zeros, three ones, how many substrings are possible? Three substrings, that is 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1. 0 1 0 0 1 1 0 0 0 1 1. So based on the minimum of these two, why are we taking this is the case. So if in case if this substring was instead of 0 0 1 1, what we had is, let's say 0 0 or 0 0 1 1 0. Okay, let's say if the substring was this. Now you start from here. Current count will be what? 1. Then you move here. Is this equal to previous character? No. In this case, what will be? Total count will be reinitialized to previous count will be initially 0. That will be 0. And the minimum of these is 0. Again, you move here. Okay. Then you have to, now previous count will be equal to current count. So that will become 1. Current count will be reinitialized to 1 because this pointer, whatever you have. So this previous count is indicative for this 0. Now you point to move it here. 1 is equal to 1. So current count will be incremented to 2 again. Okay, next again move the pointer there. 0 is not equal to 1. In this case, total count will be minimum of previous and current count. What will be? 1. So you got to know, right? Since we have a previous count equal to 1 and current count equal to 2, that means either we have two ones and 1 0, or 1 0 and 2 1 or 1 1 and 2 zeros. So either we can have two ones and 1 0, or 1 1 and 2 zeros. This is the case. What is happens? So in this, how many substrings we can possible? Only one, right? With consecutive zeros and ones. So that is the reason we are taking minimum of previous count and current count. So if they are equal to 2, then you can find two substring. If it is not equal, then we take minimum. Only those number of substrings are possible in doing this. So here you could see only 1 0 we have, but two ones are present. But we can form only one substring, because to form another substring of 0 0 1 1, here we don't have extra 0. So that is the reason why we are taking minimum of previous count and current count. So yeah, now this is done. Okay, now move the pointer ahead. So when you move the pointer ahead, again 0 is equal to 0 in this case. Okay, so before after doing total count equal to 2, updating to do, now current previous count will be nothing but current count. So current count will be 2 already, so previous count will be 2, and current count will be updated to 1 again because of this 1 0. Fresh character is starting from here because previous one is 1, that's why. So when you move the pointer here, this is equal to this, so current count again incremented to 2. Then move the pointer here, not equal, so again take the minimum of previous and current count, that is 2 only, so total count will be plus equals to minimum of this, so total count will be incremented to 4. 2 already we have, plus minimum of these 2 should be plus equals to here, so that will be 4. So why are we getting 4 here again? So the two whatever substring we have got from here, so that is this substring 0 0 1 1. This is the previous count, this is the current count, whatever. This is 2, previous count is 2, current count is 2. So two substrings are possible. And that is 1 here. So this is 2 substring. And again this is 0 0 1 1, again 2 substrings. So total of how many substrings are possible? 4. Right. Now pointer is pointing here. Again freshly current count will be, okay, will be initialized to previous count, it's already 2. So current count will be updated to 1. So next move here, again these 2 are equal, that means current count will be incremented to 2. Now once the loop is finished, but again you can find here again two substrings are possible here, this substring, but who is doing that? If you end the loop here out, if you go here it will be out of range. So how do we do that? So after the loop also again you have to check whether total count will be equal to minimum of plus equals to minimum of this and this. So after the loop also again you have to give this condition. Why? Because once you are at the end of the loop, there will be extra substring. So in this case we have the current count 2 and previous count also 2. So you have to take the minimum of those two and add it to the string. If in case instead of two ones we have only 1 1, and we'll point here current count will be 1 itself in such case. So minimum of these two will be 1. So 1 will be added, so total of 5 substrings you might get. But if you have two ones, it will be total of 6 substrings whatever you get. So yeah, this is the logic. So we shall implement this. So as I said, 3 variables. First it's current count, then it's previous count, and one more is total count. So run the loop. So current count should be initialized to 1, right? So okay, I equal to 1 we start because current count is initialized to 1, that is with the 0th index itself. I lesser than start len plus plus. If s of I is equal to s of I minus 1, then what should be done? Just current count will get incremented. Else, if there is not equal, first we have to find the total count. So total count plus equals to minimum of current count, comma previous count. And now initialize previous count equal to current count. Now we initialize the current count to how much? 1. So yeah, and as I said, after the loop also again we have to find the total count again. So that will be plus equals to minimum of current count, and then return the total count. So initialize, if it is equal, just increment current count. If it is not equal, find the minimum of 2. Then previous count will be initialized with current count, and current count value will be reinitialized to 1. So at the end again you have to do. Why this is required? because if you are in this pointer, you'll not have the case of else condition. So if you move here, it will be out of range. That's why after the loop also again you have to check for the substring. So we'll run this and check. Yeah, and for Java also same logic applies, nothing change. Yeah, same logic applies, and we assume character it function we use here, and math.minimum will be used. So we shall submit this also. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.